If I summarize the guideline, what in it for us, for people who are doing micronization? So first of all, the FDA acknowledges that the physical quality of the API is the most important factor for the performance of inhalers. Micronization is a key process in determining the physical and the chemical quality of the API. There are special emphasis on amorphization due to the mechanical impact, the number of passes during the micronizer, the overall time of micronization, which means that if you calculate residence time and every passage the material is inside for 4 seconds, if you micronize it more, then it's more time. The overall time of micronization also has to do with the time of material waits before and after micronization until it's being stored, and the rate of reduction of carryovers from previous micronization cycles. And in many cases, the micronization may be considered as the first step of formulation, and the formulator will need a lot of data about this process. And this is why whenever you produce API formulation, there are many more questions and requirements from the clients. So how do you address this? I'll start with physical characterization. Of course, the basic method is particle size distribution, either laser diffraction or something else. You will see very narrow specs and very detailed method, and it's extremely important, more than in any other product, that the client method and the manufacturer method will be exactly the same. Because we talk about tolerances of 0.5 microns, and it's enough that you prepare the sample in a different form to make a change. And also you have to account for the time. If your client is analyzing the sample maybe 1 month after you make it, you want to keep a sample and check it again in the same time, just to make sure that there is a correlation between the methods. As always, I would recommend to exchange and fully disclose the API manufacturing physical properties method to the client. It's good for the API maker, and it's good for the client. Back and tap density, of course. Then you have, of course, polymorphism and the stability of the polymorph and the amorphous content. Everything goes with that. In addition to these basics, there will be questions about the surface area, either by the BET method or by another method. DVS, which has to do with the interaction of the powder with humidity, and it has a lot to do to evaluate the stability of the powder in storage or inside the inhaler. You may be required to show the morphology by SEM, because the shape of the particles is very important because of this issue of aerodynamic properties. And in the end of the day, you need to decide how many of these you check only during development, how many of these are going into the QC monograph, and how do you, of course, control all of this. We all know how to control particle size, but it's very difficult to control polymorphism, DVS properties, just on micronization. Of course, in many cases, you need to go back and to look into your crystallization.